Hi, today we're going to talk about function word problems. On problem one, talks about Tara Spend-A-Lot had $320 in the bank. Beginning on day one, Tara started taking out $40 each day from her savings account. So she did not start with $0. And one thing is she did decrease. So she didn't increase, she didn't stay the same, she actually decreased. So what we're going to do here is we're going to complete the table. Let's just wait on the new data. We'll pick that up a little bit later on. So on day one, that'll be 320 minus 40 is 280. 280 minus 40 is 240. 200, 160, 120, 80, 40, and on day 8, she had 0 left. So over here on the graph, this is the x-axis, so this is going to be the number of days, and on the y-axis will be the dollar amount. So on day one, it'll be 0 and 320, so it'll be something about right there. And on day one, it'll be 280, so it'll be right there. Day two is 240, be right under 250. And then day three is 200, 4 is 160, 5 is 120, 6 is 80, 7 is 40, and 8 is 0. So I'm going to attempt to draw somewhat of a straight line so that you can see that it is linear. All right, now what we're going to do, let's go down and see what they want us to answer down here on letter B. On which day did Tara's savings reach 0? Well, that's obviously 8. C, which one of the following equations would represent the information above? So she started with 320 and she's subtracting $40 per day. So that would be number 3. Letter D says if the starting amount increased by $80, so the starting amount is 320. So if it increased by 80, that means the new starting amount is going to be at 400. So the withdrawal amount will stay the same. So what would be the new equation? So on number 3, instead of 320, you're going to put 400 minus 40x. And then it says, use this information to complete the table and graph the new information on the graph above. So what we're going to do, that's what this new data column is. So on 0 days, it's going to be 400. On day 1, we're still subtracting $40. So this will be 360, 320, 280, 240, 200, 160, 120, 80, 40, and 0. And then let's go ahead and extend the days. So then on day 9, she would have 40. And then on day 10 is when she would run out of money. So on letter E down here, it says how many days would it now take to run out? So it'd be 10 days. And then it says on letter F, what makes the lines parallel? Well, we need to see those lines. So let's go ahead and plot the data over here. So on 0 days, it's going to be up here at 400. On day 1, it's at 360. On day 2, it's at 320. Day 3 is 280. Day 4 is 240. Day 5 is right at 200. Day 6 is 160. Day 7 is 120. Day 8 is 80. Day 9 is 40. And out here on day 10 would be 0. So now let's go ahead and connect these points. They form a straight line. So what do you think makes the lines parallel from these two equations? The starting amount is different from 320 to 400, but the amount she took out each day was still $40. So if the rate of change, what makes the lines parallel from the equation? They have the same rate of change. Or in other words, this is the slope. So the slope of the line remains the same. All right, let's go ahead and try another one here. It says use the given problem to complete the table values graphs and answer the following questions. So now we're talking about hot water. So a pot of water at a temperature of 60 degrees is placed on a burner. The water temperature increases at a rate of 25 degrees per minute. Show how the temperature of the water depends on the amount of time the pot of water is on the burner. So before even working any parts below, see if we can figure out what the graph is going to look like. So again, you start at 60 degrees. So that's going to be up the y-axis. It's not going to be at 0. And here now we have an increase in temperature. So it's not a decrease. It doesn't stay the same. So now it's going to be an increase. So what we're going to do now is complete the table. So at 0 minutes, it's 60 degrees. At 1, you're going to add 25 to that, which will give you 85. And then at 2, when you add 25 to that, 85, 95, 105, that'll be 110. 110 and 25 is 135. And another 25 is 160. And then 160 and 25 is 185. So now we're going to come over here and plot this. So at 0, we have 60. At 2, we have, at 1, we have 85. At 2, we have 110. 3 is 135. 4 is 160. And 5 is 185. So again, this is a linear relationship because it does form a straight line. All right, let's take a look at letter B. It says, what does the 60 represent in the problem? Well, that's obviously the starting amount. You put that pan underneath the faucet and you are putting that water in there to boil your noodles for macaroni and cheese or whatever. So that's going to be the initial temperature of the water. And then it says, what part of the y equal mx plus b is the 60? Well, the m represents the mountain, which is the slope. The slope is your rate of change. 60 is not the rate of change. 60 is the beginning amount. So that's going to represent the B. The B is your beginning amount. So we're going to put letter B right there. Letter C says, what does a 25 represent in this problem? Well, again, this is obvious. It's going to be the temperature increase per minute, not the initial. We already identified the initial, and it's not going to be the total temperature at any given time. So what part of the y equal mx plus b is a 25? Well, that represents the change in temperature. It's the rate. And so it would be the slope, and the rate means the same thing. So that would represent m. All right, let's take a look at letter D. Which equation represents the data? So again, you start at 60, you're increasing 25 degrees per minute. So that would be number 2. What if the water increased to a rate of 40 degrees per minute? So that means you probably went from an electric burner to a gas burner because it gets hotter that much faster. So what if the starting remained the same? What would be the new equation? So what if the water increased to a rate of 40 degrees per minute and the starting temperature remained the same? So the starting temperature stays the same. This is what's going to change. So we have T equals 60 is going to remain the same. Okay. Now the water is going to increase to a rate of 40 degrees per minute. So that means you're not going to add 40 to 25. It's just going to bump up 15 degrees. So you're just going to put 40 right here. All right, so which of these graphs would represent the new equation? The new equation will be the dotted line. So remember, your starting amount is still the same, so it's not going to be graph 4. Now then, you're still increasing, okay? It went from increasing at 25 degrees per minute to 40. So you're not going to decrease at all. So it boils down between graph 1 and graph 2. Now, here's what we need to go back and clarify. It says, which of these graphs would represent the new equation, which is the dotted? So your temperature is going to increase much quicker. So you want the dotted line to be steeper because you're going to reach your temperature, your designated temperature, that much faster. So that would be graph number 1. I hope this helps clarify some of the things when working with some equations here with function word problems and just beginning to understand the difference between the slope and the y-intercept in an equation.